Today we will see the solve the problem 4.15, chapter 4 of Griffiths Introduction to Quantum Mechanics, third edition. This problem 4.15 consists of three subdivisions. First, we will see the subdivision A. Find the expectation value of R and R squared for an electron in the ground state of hydrogen. Express your answer in terms of 4 radius. The hydrogen atom wave function is psi NLM. Here n is 1, L0, M0, which is equal to 1 over square root of pi a cube e power minus r over a. Now we will find the expectation value of r power n. That is, we will find general solution. So expectation value of r power n is equal to r power n integral r power n, the modulus square of this wave function, integrated over an volume tq uh, T3R. So this can be written as you take this, if you take the square of the wave function, then this constant 1 over pi a cube will come, and this square of exponential term is e power minus 2r over a. This Rn I have kept as it is. I have separated this integral into three parts. TQR in spherical coordinate system is TQR is equal to r squared sine theta, this one, r squared sine theta d theta t by dr. So in order to calculate the expectation value over the entire volume, that is in spherical coordinate system. So now we got this expression. Now you separate the variable. So that is, first you take t pi. You are integrating over 0 to 2 pi. Then you are taking the theta term separately. That is sine theta t theta. You are integrating this over 0 to 5, and again this is 0 to infinite, that radial part of the equation. Now the first integral will be 2 pi. Here if you integrate sine theta, you will get minus cos theta. If you apply the limit, you will get 2. This will be 2. Then only the radial part. So 2 into 2 pi, 4 pi. You will get 4 pi. Now pi will get cancelled. 4, this 4 pi, this pi will get cancelled. We are getting this 4 pi because we are multiplying 2 pi into 2. So now you will get 4 over a cube, 4 over a cube. Now you will you come to the integral part. Now here what I am going to do is I am going to keep u as 2r over a. R is equal to, here you bring this a by 2 in this side, a by 2 u. So then dr is equal to a by 2 du. So you substitute this here. Uh, this term is nothing but you are getting 4 over aq, and same thing. Now you substitute this here. If you substitute here, this r n plus r power n plus 2 will become r is a by 2 u. So you will substitute a by 2 u power n plus 2. Then this minus 2r over a. 2r over a we are taking as u. Then it will become minus u. And dr is replaced by a by 2 du. Here you analyze it carefully. Here you have a over 2 power n plus 1. Here uh, a over 2. So if you multiply these two, this constant a over 2, then you will get a over 2 n plus 2 here or 1 1. So this will become n plus 3. So the rest of the term is here u power n plus 2 and e power minus u uh, t u. Here, when you concentrate on the limit, when r equal to 0, u are also 0. When r equal to infinite, u also infinite. So there is no change in the limit. Now we got this expression. So now we got this expression. Uh, you just see the integral part. This is nothing but your gamma integration. The answer is u power n plus 2. So naturally the answer is n plus 2 factorial. N plus 2 factorial. Now we will come to our original problem. We have to find r square. That is here n is equal to 2. So naturally when n equal to 2, this will become a over 2 whole power 5, and 2 plus 2 you will get 4 factorial. So a power 5 is this is numerator is a power 5. In the denominator 2 power 5 is 32 and 4 factorial is 24. Now you can cancel this 4 and 34, you will get 8, and this a cube and a5 you will get a square. So then again this 8 into 8, 24 divided by 8, you will get 3. Here you have a square. So final answer is a square. This expectation value of r squared is equal to 3a squared, where a is the Bohr radius. So 3 times the a square. Now, what about R, expectation value of R? You apply this formula. So here n 1 plus 3, 4. So a by 2, 4. And this factorial, n is 1, 1 plus 2, 3 factorial. So you will get 4 divided by a power 3. Then this is a power 4. 2 power 4 is 16, and this 3 factorial is 6. Now you divide this 4 and 16, you will get 4, and a3 a cube, a power 4, you will get a. Then again, if you divide 6 over 4, you will get 3 by 2 and this a. The expectation value of r is equal to 3 by 2 a, where a is the 4 radius. So we have solved the part A. Now we will move on to part B. Now part B is find the expectation value of x and x squared for electron in the ground state of hydrogen. Hint, this requires no new integration. Note that r squared is equal to x squared plus y squared plus z squared, and exploit the symmetry of the ground state. So this is the ground state wave function. Uh, we can straight away say that the expectation value of x is 0, because the x particle will move in all possible directions. So uh, average value of x is equal to 0. We will find it in the formal way. By definition, this expectation value of x is equal to integral x modulus square of this wave function T3R. So you can expand this integral between 0 to 2 pi, 0 to 5, 0 to infinite. This R, by definition in the spherical polar coordinate, this x is equal to r sine theta cos phi, and this whatever may be the wave function, modulus square of this wave function. This T3R we are writing as r squared sine theta t theta t pi tr. Now you separate the variable. So if you separate this variable, you can see 0 to 2 pi limit cos pi. Here you have cos pi t pi. So that you have taken. Here next you take the theta term. There is one sine theta here and another sine theta here. So you will get sine square theta d theta. Then rest one is the r coordinate, integral between 0 to infinite r, the wave function modulo square of the wave function, this r square dr. You can simply say, what about the first integral? If you integrate this, you will get sine pi. So sine 0 0, sine 2 pi also 0. This entire integral is going to be 0, and you are going to multiply all other things. Whatever may be the case, you are multiplying by 0. So you will get 0. The expectation value of x is equal to 0. We know that the expectation value of r squared is equal to expectation value of x squared plus y squared plus z squared. So due to the symmetry, in all direction all are symmetrical, so you can write this as 3 times the expectation value of x squared. So naturally the expectation value of x squared is, you bring this 3 to the left hand side, this will become 1 over 3 expectation value of r squared. We have seen that the expectation value of r squared is 3a squared. Here this 3 and this 3 will get cancelled. So the expectation value of x squared is equal to a squared. Now the part C is, find the expectation value of x squared in state n equal to 2, L equal to 1, M equal to 1. See, earlier case L and M are 0, symmetrical case. So this is not a symmetrical one. Then we know x is equal to r sine theta cos phi. Use this one. Uh, that is x, expectation value of x squared is, by definition, is integral uh, x squared modulo square of that wave function and T3R. So this can be separated into three integrals: 0 to infinite, 0 to pi, 0 to 2 pi. And the x squared, you know, this is r squared sine squared theta cos squared pi. And this wave function, where n equal to 2, L, M, or 1, modulus psi 211 square. Then this T3R can be written as R squared sine theta T theta T pi T R. Now the wave function for psi 211 is equal to 1 over square root of pi by a, pi a, and 1 over 8 a squared r e power r over 2a sine theta e power I pi. Now you apply this square. If you apply this, already you have r squared sine squared cos sine squared theta cos squared pi, and this, if you square it, you take the outside, take the square outside, because it's a constant. 1 over pi a, and 8 square is 64, and a squared of square is a power 4. Then you square this r will become r square, and e power minus r over 2a will become 2 will get cancelled, e power, just this is e power minus r over a, and this sine theta will become sine square theta, uh, except this exponential, this is, remember that modulus square, then this complex conjugate of this one is e power minus I pi. So if you multiply both, you will get 1. So you can ignore this exponential term. Then you take rest of the term, r squared sine squared theta theta t theta t by t r. Now you separate the variable. Now first you take the pi term. So there is only cos squared pi. There is cos squared pi t pi. So we are integrating it over 0 to 2 pi cos squared pi t pi. Then you club all the sine squared theta term. Here you have sine squared, here you have sine squared, here you have sine theta. So you will get sine power 5 theta t theta, and r term you have here r squared, here one r squared, here one r squared. So this will become r power 6, and this exponential term e power minus r over a t r. So we have separated the variable, and also you can reduce this, simplify this constant. Here you have a, and a power 4 become a power 5. This pi you have, and 64. This all this constant will become 64 pi a power 5. So now we have separated the variable. Now we will see this integral. After the separation of variable, we got this expression. First, we carry out the radial part of the integral, which I labeled as I of r, which is equal to integral 0 to infinite r power 6 e power minus r a d r. Here, I have taken u as r by a, and that means r is equal to, if you bring this a this side, the left hand side, r is equal to au, then dr is equal to a du. You substitute all these things here. That is r is equal to au. This r is equal to au, and this r by a is equal to u. This r by a is equal to u. This tr is equal to a du. This tr is equal to a du. Now after substitution, this is a power 6, u power 6, first term. Then next exponential e power minus u. You will get u power minus u, and there is a du. Now you have a6 here and a here. So a power 6 into a will become a power 7. I am taking out because that is a constant. So inside the integral you have u power 6 e power minus u. So this is gamma integral. So here you have 6, so u power 6. So this gamma integral is 6 factorial, and already you have a power 6 here. A power 6 times 6 factorial. 6 factorial is 720. So this will become 720 a power 7. Now you take the theta integral. So I designated as I of theta, which is equal to 0 to pi. This here you have power sine power 5 theta. So which I have written sine squared of square, that is sine power 4 is sine squared of square. That sine square I am replacing by 1 minus cos squared theta. 1 minus cos squared theta is equal to sine squared theta. You know, the sine squared theta of square is sine power 4, and I have taken one sine theta. So I have separated sine 5, uh, sine power 5 as 1 over, 1 minus cos squared theta whole square sine theta. So now we will find out the this part of integral. Now the theta integral is 0 to 5, 1 minus cos squared theta whole square sine theta d theta. Now you take cos theta as u, then du is equal to minus, remember that this is minus sine theta d theta. Now you replace this here. So 1 minus u squared whole square, this sine theta d theta become minus tu. So here when the theta equal to 0, limit also you got to take care. When theta is equal to 0, cos theta is 1. When theta is equal to pi, then cos theta is equal to minus 1. You remember that. Now I am changing the limit. That is it. This is symmetrical one, so I can take two 0, 1. See, I am changing the limit minus 1 to minus 1 to minus 1 to 1. So then this minus will go away because I am changing the limit. And due to symmetrical property, I can take this as 2 integral between 0 to 1. And if I square this, a square plus b square. B square is u power 4 minus 2ab. 2ab is 2u squared. Then this 2u, tu. This minus sign, as I said, I am changing the limit, so that will go away. If you integrate this, you will get u. First term is u, second term is u power 5 over 5. Second term is 2 minus 2 u power 3 over 3. Apply the limit 0 to 1. You apply the limit 1. Then first term is 1. Second term also 1 over 5. Third term minus 2 over 3. So if we take 15 as common, then first term 15, this is plus 3 and minus 10. So you will get in the numerator 18 minus 10, 8. There is 2 in the outside. So 2 times 8 is 16. 16 over 15. Then we will see the pi integral. I referred as I of pi. If you integrate between 0 to 2 pi, this is cos squared pi t pi. Cos squared pi can be written as 1 plus cos 2 pi over 2. This can be written as half cos 2 pi over 2. So remember that the second part, if you integrate it, you will get sine. So naturally, sine 0, 0, sine pi also 0. So don't worry about second term. First term 1 over 2. If you apply the limit, you will get upper limit. Uh, if you integrate it, you will get pi divided by 2. When you apply the upper limit for pi, you will get 2 pi, lower limit is 0. So in the numerator, you will get 2 pi. In the denominator, already you have 2. 2 will get cancelled. So the final answer is 5. So this the pi part of the integral is pi. So now we got the expectation value of x squared after separating the variable like this, and each for each variable we have found the value. So the first integral 0 to 2 pi cos squared pi uh, t pi is pi. Just now we have seen. Similarly, this sine power pi t theta second integral between 0 to pi is 16 over 5. The radial part of integral we have seen that is equal to 720 a power 7. So you substitute this first constant 1 over 64 5 pi a power 5. The next one is pi. Then next 16 over 5. This is 720 into a power 7. Now you can cancel out some of the term. See, first you can take this 16 and 64. You will get 4. And next pi, this pi and this pi will get cancelled. And this a power 5 and this a power 7 will become a squared. And this 15, this 720 will become 48. So now 48. So now you will have 1 over 4, first term 1 over 4, and then 48 times this a squared. Now 4 and 48 divided by 4 is 12. We got this 12. That is, this is 12. So the expectation value of x squared is 12 a squared. So this is the answer for our third part. Thank you very much for watching my video and supporting me continuously. Thank you very much.